So like I mentioned again and again, the vertex form of the parabola, very quick way to graph. We love that. At this point, we just don't have the algebraic skills or the know-how to make everything be vertex form, but we're very close. We're very, very close. So what we have to do is kind of use the cheater's method. You know, we can find the vertex. We have a little formula for that. You know, we had our negative b over 2a. And then we said, if we want the vertex, all we have to do is put that back in the function. And that'll get us the vertex. So if we can figure that out, that would give us h and k. We can do a little bit of math, find a, and we can get it to be in vertex form. Now, usually, if we're just graphing, that's a lot of work to get that to happen because we can graph it as we go through that process of finding the vertex and using 0c. But if we really, really want to see everything in vertex form, we can make it happen. So this one says, what's the vertex form of 2x squared plus 10x plus 7? And we identify our a, b, and c. And just like we did yesterday, we say, hey, that axis of symmetry is negative b over 2a. So that's going to be negative 10 over 2 times 2, which is negative 10 fourths. Wait a minute, we can reduce that. Negative 5 halves. So it didn't work out to be an integer. Big deal, we can handle it. So what do we have to do with that? Now that we have that axis of symmetry, x equals negative 5 halves, what do we do with that to figure out what our vertex is? Plug it in. Now be honest with me. Are you going to do that by hand or are you going to grab your graphing calculator? Unless put her in the graphing calculator. Alrighty, so we have 2x squared plus 10x plus 7. So 2 times our little negative 5 halves squared plus 10 times our little negative 5 halves plus 7. Math number 1. There we go. Negative 11 halves. So we know what the vertex is. That means we know what h and k are going to be. And then we think, okay, so if I know all of that, the other piece I would need is a. We already know a. We do, don't we? What is a? It's 2. Cool. We don't even have to find another point and plug it in for this one. We know a is 2. So we start thinking about our fabulous little h and k formula. And we realize all we ever had to do to figure out this in vertex form was find h and k, which we did. That's the vertex. Negative 5 halves, negative 11 halves. And a. Before, we had to do math to find a. We don't have to do any math anymore. So the toughest thing about that is going to be remembering when we put in that negative 5 halves into x minus h, it'll become x plus 5 halves. So, fractions, they're not so scary. Who cares? That wasn't tough. We find the vertex. We could use our graphing calculator to figure out that y coordinate of the vertex. A is going to be right there. There's no mistaking it this time. And we get it. There's one for you. Oh, that's good news. It's been a few days since we had candy. So start on this one. I'll get you candy. Pretty good. It sounded like people were catching people's little mistakes as they went through this. So our A value, negative 1. Our B value of 4. Our C value of negative 5. Then you do your little negative B over 2A. So negative 4 over 2 times negative 1 gives you a positive 2. And then here's the thing people were asking about as I walked around. If we plug that back in here, The question is, does the negative go with the squaring? And the answer is absolutely not. And that's because powers only go to the closest thing to their left. If there were parentheses here, then yeah, we'd take the negative 2 and square the whole thing, but there's not parentheses. And the order of operations says you're going to do this power first, then you're going to multiply it by a negative 1. So this is going to be negative 4 plus 8 minus 5, and negative 4 plus 8 is 4, and 4 minus 5 is a negative 1. So we get our y value when we put that 2 in there of negative 1, which gives us a vertex of 2, negative 1. So this didn't have fractions, but it did have its own kind of little challenge, you know, as you went through there. You have to remember, powers only go to the closest thing to their left. So if there's no parentheses, you just treat it as the order of operations. And then we write this little bugger in vertex form. And our a was negative 1. And that would miss like a half a point. Why? What's wrong with it? It's pretty. We don't need the 1. We don't need this one right here, do we? And we don't want it there. It's unnecessary. You know, and that's because we know if there's nothing there, it's a 1. So to simplify it, we would leave it like that. All right, so if everybody can find a spot to sit for a little while, I am going to have you work with your partners again. Just a bit. You know what? No, go back to your seats. Thank you, partner. Go back to your seats.
Thank you.
Hey, I gotta go. This appears to be a very intimidating word problem here. The New River Gorge Bridge in West Virginia is the world's largest steel single arch bridge. So just one of these, you know, you can see bridges that have multiple arches, but this one is just the one arch. And you can model the arch with this function right here.
Oh, that's
Look at that monster, huh? Where x and y are in feet. All right, how high above the river is the arch? How long is the section of the bridge above the, oh, that's the first time I've ever noticed there's 2 thes there. How long is the? Do you have the in your packet? The section of the bridge above the arc. So here's what we have to do. We have to figure out, first of all, how far it is down to the water. But if we're going to figure out the height of the arch, we also need to know this. And the reason I'm doing this is because I want you to see this is about the y. I mean, we're talking about up and down. So we need the y. And that's why when we talk about maximum or minimum, you know, people want to say it's the maximum of and then give you the y coordinate. Let's see if we can figure this out. We've got a little diagram over here. And it seems to be kind of pointing us in the right direction. But you know what? I'm not going to get exact stuff if I go over there, and I want exact. So can we find this point exactly?
Yeah.
What is it? But if we had to find it, how do we get it?
Oh, that I will get in.
Yeah, the negative b over 2a. We can do it. So we go back up there and we say to ourselves, self, that looks like a whopper of a problem up there. How could I figure out negative b over 2a? And there's no c in the back. Well, we don't need c. All we need is the b value and the a value, which is this obnoxious number right here. And that would give us our x-coordinate of the vertex. So, according to what you have in your packet, this works out very nice. So let's see. Negative 0.847 divided by, parentheses, 2 times, negative 0.000498. And we get that. Now, because this is an estimate type of thing, we're not going to worry too much. I guess I would really like to go to 850.4, but the book says that 850 is kind of good enough, you know, so we'll go with 850. So we just figured out the x-coordinate of the vertex. Now, that's going to be helpful, but for what we were going to do first, which is the height of the arch, we haven't gotten a y yet. So what do we do with that monster to get the y? Plug it back in, yeah, to that obnoxious formula we have up there. So y equals, cheaters back on, negative 0.000498 times our 850. Then, oh, yep, that was good. And then we've got plus 0.874 times our 850. I should have started writing a little farther over to the left. So let's see what comes out of that.
It's not 874, it's 847.
Oh, there's another typo in mine. You guys' is fixed. 847? Thank you. Yeah, mine has it typed up as 874. I better get that off there. Negative 0.000498 times 850 squared plus 0.847 times 850. So around 360. Take the parentheses off of there too. All right, so let's go back up to the diagram. That's really small. Hopefully, that'll be enough for us to answer the problems that we have here. Now, what I was just doing by holding my fingers up like this to show you we were looking for y was finding that height of 360. But it's not 360 and then you hit water. There's another 516 there. So to get the height, we're going to have to take 360 plus 516. And that actually is something they do on the MCAs a lot. You think, hey, I found the answer, it's 360. You look down there and you pick 360, and you go on to the next one and you realize, wait a minute, I forgot to add the height that was already there. So they do that quite a bit on the MCAs, just to make sure everybody's paying attention. So 876 feet high. That wasn't the only piece of info they wanted. They wanted to know how long the bridge is. Now, I'm hopeful that we have that information up here somewhere, or a way to find it. Ideas? Okay, do you see how it was helpful that we put that the height of this thing was 360 over here? So maybe this will be helpful if we put that from here to here is about, that's a really bad bracket. Now do you see how we could get the height? They're always symmetric, so just 850 times 2. The drawing a picture thing is a really big deal. I mean, if you take an ACT prep course, you're going to find out that all the teacher is doing for you is showing you draw a picture. You know, make sure you're labeling everything as you go. Because once you have that visual, bam, you can figure out what it is you need. You know, but you got to label things like crazy. That is an example of an MCA type problem. The MCA type problems are never just find the slope, find the height. There's always a problem that goes along with it in word problem form. So that's a really good one. Now, what about something like this? Well, this isn't MCA, but this is something we should know how to do. And it says for each function, the vertex of the function's graph is given. Find the unknown coefficients. Well, there's too much missing there. How are we going to be able to figure that out? Well, let's just start with what we know. Supposed to find that. Do we know any of them? We know B. So I start to think, do I have any formulas that would use B that might help me find something that's missing? Okay, we have x equals negative b over 2a, right? Well, I know that's a 10. I don't know what a is. Do I know what I get for x when I put this in? I do. What number up there tells me what I get? Exactly. This is the x-coordinate of the vertex. Remember, that's where we get the axis of symmetry and the x-coordinate of the vertex. We're going to be able to figure out what a is. First problem is a is in the denominator. You cannot solve for something that's in the basement. You can't do it. So probably the quickest way to get what you need out of this is to slap a 1 under here and cross multiply. That's probably the quickest way to get what you need. Otherwise, you'd multiply both sides by 2a. In the end, we're going to get exactly the same thing. Good news, a is 1. A is 1. Well, now we're short one number there, and that's c. So now I think, do I have any formulas that I could use to figure out what c is? Well, I can't use that because this doesn't even have a c in it. And I realize, okay, I better plug in what I have to see what's missing. So I know this is a 1, and yes, I'm going to write the 1 down so that I know I've got it. I start thinking, if I'm going to find c, I have to have something for x and y, because there's 3 variables here. If I want to solve for c, I need stuff to put in for the other ones. Do I have stuff to put in for x and y? What stuff? Here it is again, -5 and -27. This says, when you get this formula written like the way it's supposed to be written, it's going to give you this. So we'll get a -27 if we put a -5 wherever we see an x. And now look at that. The only variable we have there is c. We're going to find it. We're going to know what it is. So -27 equals, you guys tell me, what is this going to be? Good, 25, because the parentheses there, we're putting the -5 in. So 25 minus 50 plus c. -27, 25 minus 50 is -25. We add 25 to both sides. And c is a little -2. Oh, yeah, first basket right there. All right. Did we find everything they wanted us to find? For each function, the vertex of the function's graph is to find the unknown coefficient. So maybe we should just circle this so that somebody can find it really easy, or put it back up here so people know, hey, we found them all. But they don't want us to go back and write it, is what I'm getting at. Sometimes you'll find out you do all of this and they'll say, what is the equation? And you'll have to actually go back and put in the A, B, and C in order to see what it is. But that's just algebra, and that's what that is. You use what you know to find what you don't know. So let's do a little review here. What does standard form of a quadratic look like? ax squared plus bx plus c, right? So there's our standard form. We've been talking about quadratics now. This is the 4th day we've been talking about quadratics, so we know a lot at this point. Y equals ax squared plus bx plus c. Now let's just talk downward here about standard form. How do you find the axis of symmetry? There it is. And that we're just going to memorize. You know, that's one of the things I love about vertex form. It's not so much memorization as just knowing where to find stuff. But axis of symmetry is negative b over 2a. So that x equals negative b over 2a, that helps us find the vertex, right? So it gives us the x coordinate. How do we get the y? Put it in the function. Let's see what we get. So negative b over 2a, and then in the function, put that negative b over 2a. Do you remember where the y-intercept is? 0c, 0c. Remember, if you want the y-intercept, you always make x equal to 0. So usually that'll trigger you. You go like, oh yeah, if x is 0, 0c. That's where that y-intercept was. Maximum or minimum? Well, we know all that depends on a, you know. But what we're always going to be using is that y-coordinate of the vertex. That's our max or min. And some people are having trouble seeing, so I'm going to try and squirrel this a little bit closer. So it's the y value that matters to us for the maximum or the minimum. Vertex form. Remember it? Y equals a parentheses x minus h squared plus k. Good, good, good. Now when it was absolute value, it was y equals a absolute value of the quantity x minus h plus k. But now we're talking quadratics, still a, h, and k. Where's our axis of symmetry? X equals h. Still vertical, still karate chopping the x-axis. Vertex? Love that. So quick and easy to find the vertex, which with word problems is often a big part of your answer. Y-intercept. Is it always k? Basically what you have to do is plug it in. You know, it could be, it comes out to be 0k, but really we don't know. We have to plug that 0 in. Like I said, the way to think about y-intercept is, if I put a 0 in for x, what am I going to get? And that's what this says. You've got your 0, now plug it in. You know, what do you get when you do that? Max or min? Where does that occur in vertex form? HK. We've got that k value, so you think about your vertex and you focus on, hey, it's just the y part of that. So that's my k right there. 4, 3, 2, 1, 0 mean not just on today's, but overall how you're feeling about the first 4 days here on quadratics. Where's everybody at? So do you agree? A lot of this was just review of what you did in exponential. Did it kind of come back to you as you went through it? Yeah. Some of the stuff, like the last one that we just did, that's algebra 2, and that's because it's a lot of algebra that you have in there. But a lot of this is review of exponential. So away we go. There it is. Oh, and then we do skip 4-3. 4-3 is using the calculator to generate some equations. But we're going to 4-4, and some of you are going to love it, and some of you are going to go, oh, factoring. We get into factoring big time over the next few sections. Lots and lots of factoring. Every factoring problem you have ever done.